Niffenegger. I'm a staff engineer at Iterable. I'm going to try to avoid keeping everyone from lunch too long. What I want to talk about today is how we're scaling our company Iterable with Pulsar. That's a little vague. What I really want to dive into is how Pulsar fulfills two things for us. One is an engineering productivity front, where we have a really diverse set of products, and we've used Pulsar perhaps in a counterintuitive way to most people to support our engineers. And two, how Pulsar supports our rather unique traffic patterns. Great. So, I'm a staff engineer at Iterable. I'm in charge of Team Q, which provides queuing as a service to all the teams at Iterable. Over the past 2 years, we've migrated from RabbitMQ to Pulsar and overseen kind of this routine doubling in the number of messages we see queued every day, and the routine doubling in really the complexity of our platform for queuing. Anything that a team does at Iterable with queuing goes through a library that my team wrote or through infrastructure that we manage. So I'm not going to take too long. I'm going to introduce us to Iterable really quick, why you should care about Iterable, why you should care about Iterable's usage of Pulsar, why we're using Pulsar and not something else, and kind of what we were thinking about when we made the decision to migrate. I'm going to skip the whole migration story and go right into why we have a topic architecture that pushes the limits of Pulsar and does things that you probably can't do with other queuing systems. And then also dive into kind of a second side of things where Pulsar really helps facilitate our infrastructure, or our growth as a company, and keep our costs down, and then kind of just wrap it up. So, who is Iterable? Iterable is a customer engagement platform. We send messages for our customers to their customers. Those can be simple things like email or blast campaigns, or they can be really complex, long-running interactions over months, or with really low latency. Our platform is flexible. It does lots of different channels. It supports lots of different message types. The idea I want you to get through here is we have lots and lots and lots of different things we need to queue with lots and lots of different requirements around them. It's not unusual for us to see 10 billion plus messages a day. The rate we're growing, we're going to be well beyond that very soon. So, why Pulsar? Iterable historically used RabbitMQ. RabbitMQ is great to get started. Unfortunately, you kind of run out of runway with RabbitMQ at some point. At scale, we reached our limits with it. We were throwing money at it. We could see the writing on the wall. But when we made the switch, we kind of thought about some things. So we thought about, if we're going to make this switch, how do we design a queuing system that fits us? And the reason you should care is because what fits us is different from other people, we think. Our platform is really flexible. It supports customers who use us in extraordinarily different ways, who hit our systems in extraordinarily different ways. And we need a queuing system that lets us isolate customers from each other completely. Why? Because their interference with each other is really detrimental, and even their interference for workloads within a specific customer, it can be really detrimental. So we need that isolation, but we also need a system that's really flexible that lets us build a ton of products really quickly to fit our market, which is really built around supporting a ton of different products and a ton of different integrations. The second thing we need from a queuing system is the ability to support growth and bursts in traffic. So most people think about growth as being smooth. For us, growth happens in bursts, right? We onboard a new enterprise customer who increases our load 20% overnight. We introduce a new queuing use case that increases our load 20% overnight. The growth for us is not something that we want to spend time day-to-day planning. We don't want to add servers, or we don't want to add broker or bookie instances. We don't want to be worried that the next thing we're going to introduce is going to break our queuing system. And it needs to degrade. It needs to not degrade when this happens. The second thing is We don't have smooth traffic, and I know a lot of people say that, but Iterable really doesn't have smooth traffic. We can 10x our traffic in seconds. So that could be because Taylor Swift decides to attend a Chiefs game. Anything, any external event, someone could decide to send a campaign to hundreds of millions of people. And with RevenueQ, you can't really fix this without throwing a ton of money at it. We need a queuing system that can handle these bursts gracefully. And so that's why we chose Pulsar, and I'll talk about how that's worked out for us. So those are the two things we're going to talk about. First, I want to talk about our topic architecture. So when we migrated to Pulsar, we chose a topic architecture that leverages what Pulsar gives you. And what Pulsar gives you is the ability to do stuff that's kind of ridiculous. So at any given point, we're running 100,000 plus topics on Pulsar and millions of producers and consumers. And we're doing that using things that probably most people aren't doing at scale, which is auto topic creation and regex-driven consumption. So what this looks like at a broad scale is each customer has their own topic or set of topics. And you can do lots of things to prevent customers from interfering with each other, but Pulsar gives you a really easy one, which is just throw a lot of topics at it. This has worked out really well for us. It allows us to avoid a whole set of engineering concerns. Some of the things it gives us complete customer isolation within our queuing system. We don't have to worry about interleaving messages. It gives us prioritization using regex consumers, so we can prioritize messages or at a workload level. It gives us rate limiting and back pressure at the workload level, at the customer level. And it also gives us, as a neat little side effect that you might not anticipate, observability. So I said auto topic creation. What does it look like? Simply what it looks like is every producing service decides how they want to split out workloads. A workload at our company is a product usage by a specific customer. So a customer can have a messaging campaign for emails. That's one workload. A messaging campaign for SMS, that's another workload. They can have a transactional version, a blast version. They can have dozens, hundreds, thousands of workloads. Those are each topics. These workloads are actually ephemeral. They come into and out of existence. So you can use auto topic creation to create topics. You can also use auto topic deletion to clean up topics. So our workloads and our topic structure, infrastructure actually is shifting, is dynamic. Actually. So this is a big inversion from what you would normally do. You might have some service controlling the number of topics. You might make it declarative for your topics. You might have it being consumer driven. We inverted that. And you might say that this won't work. With Pulsar, it does work. It works pretty well. We're running hundreds of thousands of topics. We're running millions of consumers and producers. The way Pulsar is architected, the client has a fixed number of connections to the broker, each broker. So adding consumers and producers is not really a hit to the brokers in any way. You can do this. And in fact, we can talk about what the limits of it are, but really what we found is the limit is not the number of topics, it's actually the number of consumers. As long as you're smart with it, you can get away with it. So customer workload isolation. So this is what I said was number one for our company. We have customers who use us in drastically different ways. We don't have to worry about that from a noise neighbor issue. A customer can enqueue 100 million messages for their campaign. That's going out to everyone in the country over a couple hours, and they can also send a transactional message in a second. Those go to different topics, they're on different workloads, prioritized differently. We don't have to worry about it from a queuing perspective. We'll talk more about grouping the workloads, but another interesting part of this is when you do this split, we have some truly massive customers. Whenever you do partitioning at this level, you're actually horizontally scaling at the workload level, which is a really intuitive thing to do. So for our truly, 99% of people when you're doing this model aren't going to need partitioning, but when they do, you have a really clear way of, oh, this customer needs 3 times the capacity. I'm just going to add a couple partitions, and that's where they're at. So how do you get those hundreds of thousands of topics down to something consumable? Use regular expression consumers. Regular expression consumers allow you to group topics, using a regex, right? But in our case, that abstraction means that you're actually grouping workloads. So you can group bulk workloads, you can group transactional workloads, you can group email, SMS, whatever. You can group them by customer, you can group them within a customer. And so every consumer decides how they want to group these workloads and then how they want to apply our library's primitives on top of them. To be clear, the way our regex consumer works is really helpful here. So let's say you match 10 topics with a regex. The client makes 10 consumers. The client makes 10 consumers and then groups those into a single stream of information that's exposed via the API, right? So you've taken all these topics and you condense them down into one thing, one abstraction to use. So when you do that, it becomes pretty obvious what you'll do next. You'll apply lots of primitives to that, like back pressure and rate limiting. This is really important for us because of the flexible way people use our platform. If you have someone who hits your database 100 times harder than someone else for each of their operations, because one detail of our platform is we basically allow arbitrary queries on your data with ridiculous levels of nesting and complexity. When you have that, you need some form of back pressure to limit how each customer impacts your downstream systems. With regex consumers, with this workload logical grouping, you can say these workloads, which I know hurt us more, are going to get this capacity. These workloads that I know hurt us less are going to get this capacity. And you can do the back pressuring and rate limiting in there. So it's a lot easier to think about your system when you do this because you're doing things at an abstract level. You're saying, I'm grouping these workloads and I'm doing this operation on them. So that's something that our engineers use quite a bit. And then the last big thing you get out of this architectural decision is you get observability. Now, you might say 100,000 topics, can Pulsar really report the metrics for that? Can downstream systems handle that? Yes, they can. And because they can, you can do things like look at the performance of a workload longitudinally in your observability system, Grafana, Datadog, whatever. So you can look at how fast you go through your backlogs. You can look at how long consumption takes. You can look at how long or how different workloads even interact with each other. And so for our engineers doing investigations or on call trying to figure out what's happening with our system, it's really intuitive to see where things are coming from. So I want to jump. That's our topic architecture. We can ask questions about that if we want. But as far as scale goes, how Pulsar supports our growth, our company is growing rapidly. We rarely increase the scale of Pulsar. So maybe once a year we add brokers or bookies to it. And how you get there is because of something that's a bit understated about Pulsar, which is that every version of Pulsar is easily 20 to 30% faster. CPU, RAM, bookie disk write speeds. The runway for Pulsar for getting faster means that for us, we're not increasing infrastructure costs much, if ever, in a lot of cases. And we regularly have these records for us. We onboarded our largest customer this year. We added our largest new queuing use case this year. We've seen enterprise customers triple their usage. We actually have to add monitoring in our observability systems to see these things because we won't notice them in Pulsar otherwise because every minor version is so much faster. And then as far as bursts of traffic goes, So they're talking about load management. I think it was 2.6 or 2.7 topic load balancing was introduced. Because we split things out by workloads and we know that specific workloads are spiking, topic load balancing for us is essentially workload balancing. So it distributes our workloads across our brokers, and it means that these spikes that we experience are basically non-events. We don't think about them, we don't worry about them, we don't throw money at them. And on top of that, our experience with Pulsar has been that you can tune the brokers and bookies to the type of events or to the type of messages you're seeing, and you actually need different tuning for different types of messages, specifically delayed messages versus regular messages. And we use a ton of delayed messages. So what does that mean for us? It means that queuing has kind of gone from a liability for us to a strength. Queuing usage for us, I know I've taken the numbers off of it, queuing usage for us easily is doubling year on year. And it's increased so dramatically because Pulsar just works. People don't have to think about whether their new use case at new unheard of scale is going to work. It will. They don't have to worry about if their new thing that needs like ordering or delays or whatever is going to work. It will. And for our teams, they don't have to maintain anything. They just set it up and it's kind of fire and forget, right? So on top of that, the topic architecture really works in our favor. Teams don't have to think about what they're doing from their perspective. The only thing they do is they provide a naming convention for their topics, for how the topics are generated, which is really interesting because, and I forgot to mention this, it can be flexible. So you can change it depending on the load on Pulsar, or the load on downstream systems, you can change how you're generating your topics, which is basically how you're partitioning your workloads. And then on top of that, our infrastructure growth is flat at this point. With RabbitMQ is not going in the right direction. So what does that mean for the company? For Iterable, it's meant that we stop thinking about scale at a short-term basis. We're thinking about long-term scale. We're not thinking 6 weeks, 6 months from now. We're thinking 5 years, which is about the limit. It means that our engineers, whenever they want to, can bring something new into queuing. So for us, that's really important because we're constantly coming up with new products. That's kind of the feature of the vertical that we're in. And it means that we're making sustainable investments in queuing where we really weren't before, or we really weren't headed in that direction. And that's all I got. So.